Hello student, welcome back in the classes of operating system 2. Now in today we learn about memory management schemes. Now in memory management we already learn about the paging. In today we learn how to use paging in shared pages, two-level paging and different paging structures. So let us see memory protection. Before we learn shared pages, how to paging is possible with the sharing environment. First we learn about the memory protection. Memory protection is needed because sometimes the page contain read-only or read and write. Fine, so at that time the page environment is used some protection bits for each and every frame. There are two different types of bits. One is the valid, it is defined by V, and one is the invalid, that is defined by I. The bits are kept in the page table. Now only one bit can define a page table and the page is to be read write or read only. Every reference to a memory goes through a page table to find the correct frame numbers, and at the same time the physical address is being computed and the protection bits, which is invalid bit or valid bit, which can be checked to verify that no writes are being made to a read only pages. That means ऐसे कोई read only pages में write operation ना कर दे, इसके लिए valid और invalid bits use होते हैं for the protection. Now for attempt to write to a read only pages, page cause the error. That means कि अगर कोई read only pages है और उस पे write operation perform करने जाए तो operating system क्या करेगा? It gives the trap, मतलब कि hardware trap. That means it is an error of the operating system. There are two different bits, valid and invalid, which is attached to each and every entry in the page table. That valid and invalid. Valid is defined by V and invalid is defined by I. Valid means what? It indicates that the associated page is in the process logical address space and it is a legal page. ऐसा पेज जो मेमोरी के अंदर है, एड्रेस है उसका, तो वो वैलिड हुआ. पर ऐसा पेज जो मेमोरी के अंदर लॉजिकल एड्रेस स्पेस ने वो पेज प्रोवाइड किया ही नहीं है, तो वो इनवैलिड बिट है. सो इनवैलिड बिट इंडिकेट्स दैट द पेज इज नॉट इन द प्रोसेस लॉजिकल एड्रेस. दिस इलीगल एड्रेस आर द ट्रैप बाय द यूज ऑफ वैलिड एंड इनवैलिड बिट. जो इलीगल एड्रेस होगा वो कैसे हम फाइंड करेंगे? थ्रू द वैलिड और इनवैलिड बिट. इलीगल एड्रेस पे आई डिफाइन होगा, एट जो वैलिड हो गए, जो लॉजिकल एड्रेस स्पेस ने डिफाइन किया है, सीपीयू ने जो डिफाइन किया है, वो वी से डिफाइन होगा, दैट इज द वैलिड पेज. सो आर यू गेटिंग व्हाट इज वैलिड एंड इनवैलिड? वैलिड इंडिकेट द प्रोसेस or the pages which is available in the logical address space. Now let us see some example of valid invalid page. See over here. This is a page table which contain two different value. One is the frame number and one is the valid invalid bit. And this is the index 0, 1, 2, 3, 4, 5. What is it? It is an index. This is the frame number and this is the valid invalid bit. Now this is the logical address space which is provide some pages. Page 0, page 1, page 2, page 3, page 4 and page 5. This is the logical address space. Now for example, the system contains 14 bits addresses that provide 0 to 16,383. From 0 to 16,383. Okay, now we have a program that should use only the address of page 0 to 10,468. Now, every page size of 2 KB. Now, addresses in the page 0, 1, 2, 3, 4, 5 like that, 6 and 7. But see over here, from 0 to 5, all the bits are valid. That means all the page are valid. Yes, this is page 0, page 1, page 2, page 3, page 4 and page 5. जो logical address ने हमें provide किया है वो page 5. That means that all are the valid page. But the logical address space doesn't provide the page 6 and page 7. logical address does not provide the page 6 and page 7. So that's why it is invalid page. It is invalid page, and invalid page की entry physical memory में नहीं हो सकती. So over here, see, this is the page 0 and it is available on second frame. This is the page 1 and it is allocated to page 3. This is a page 2, it is available on frame 4. This is a page 4 that is available at page frame 8. This is a 5, it is available on frame 9. The 7 that is available at page 3. Okay, so over here, that all valid bits it set to the pages, and that pages is allocated the frame number over here. But same way, the page 6 and page 7 does not provide by the logical address space. That's why it is invalid bit, and invalid bit does not contain any frame number in the physical memory. So the addresses in the page 6 and 7 will find invalid bit. So the computer will trap the error. 6 and 7 का invalid bit है, that's why the computer error generate करेगा. So the reference to 0 to 5 are classified as a valid, and the address is 0 to 12,287 is valid, but from 12,288 to 16,383, यहाँ से जो 12,288 से 16,383 are invalid address space. So are you getting this valid and invalid? Valid bit वही होगा जो लॉजिकल एड्रेस हमें प्रोवाइड करेगा. लॉजिकल एड्रेस स्पेस में जितने पेज जनरेट हुए वही हमारे वैलिड बिट होगा, और वही वैलिड सेट कर सकते हैं हम, और जो वैलिड बिट सेट होगा उसको ही फ्रेम अलोकेट होगी फिजिकल मेमोरी के अंदर. So are you getting this? Valid, invalid bit, it is used for memory protection. Now, next example for the shared pages. What is the shared pages? See, shared pages is one of the advantage of the paging, and which is used to sharing some common code. It is important only and only for the time sharing environment, and it use the code that is a pure code, re-entered code. And if the code is re-entered, it can be shared. अगर re-entered code होगा तो ही वो shared हो सकता है, otherwise नहीं. So what is a shared code? Shared code contain a one copy of read-only code that share among the different processes. For example, text editor share कर सकता है, compiler share कर सकता है, Windows system share कर सकता है. That all shared some sharing code among some processes. Then share code must appear in the same location in the logical address space of all processes. जो sharing code होगा which contain the same location in the logical address space. Now the private code and the data. What about this data and the private code? This shared code contains the same addresses in the logical address space. Same way it contains same frame number in the physical memory. Now the private data and private code. What is it? Each process keeps a separate copy of each and every code and each and every data. That is a private code. Now that pages for the private code and data which can appear anywhere in the logical address space. जो प्राइवेट कोड और डेटा होगा वो फ्रेम डिफरेंट यूज करेगा फॉर द डिफरेंट प्रोसेसेस. फाइन. सो द री एंटर कोड इज अ नॉन सेल्फ मॉडिफाइड कोड. इट नेवर चेंजेस ड्यूरिंग द एग्जीक्यूशन. नाउ when two or more processes can execute the same code at the same time, so at that time the sharing code or sharing pages is usable. Now the each process has its own copy of the register and the data storage, which is used to hold the data for the process execution, and the data for the different process will be different. The sharing pages is only and only common for every process, but the data for different processes will be different. Now only one copy of the editor need to be kept in the physical memory, and each and every user use that copy from the physical memory of editor. But the data's private data which cannot used by different processes, it is mapped with the one different frame. Now the sharing of memory among the process on a system is similar to the sharing of the address space which is available in thread. Now the shared memory can also be described as a method of inter-process communication, which is already we learn inter-process communication में shared memory use होता था with sharing some common task. So the operating system implement the shared memory using the shared pages. Now let us see some example of shared pages. See over here, there are three different process: process 1, process 2 and process 3. That three different process contain separate page table for process 1, page table for process 2 and page table for process 3. But see over here, there are some text editor, editor 1, editor 2, editor 3, which is shared by each and every process: editor 1, editor 2, editor 3 for process 2, editor 1, editor 2 and editor 3 for process 3. So this all editors are common and it's sharing a common address space in the logical address. Same way, see over here, editor 1 is stored in the page 3, frame 3, editor 1 for process 1, that is in the frame 3, for process 3, that is in the frame 3. So same way, editor 1, 2 and 3 share this common frame from the physical memory, that is 3, 4 and 6. So at the 3 number frame the editor 1, at the 4 number frame the editor 2 and the 6 number frame editor 3. Now this all three process share this editor as a common space in the physical memory. But see over here, process 1 use data 1, that is a private data. Process 2 use the data 2, that is also a private data, and process 3 using data 3, this is also a private data. That private data does not share by any address spaces in logical address memory and in the physical memory as well. So how it is important and why we use shared pages? See over here one example. The read-only pages are shareable. That means it is a programming text or text editor. But the data pages which are not shareable. So consider one example like a system support 40 users and that all execute the text editor. We have a 40 users and that 40 users need to access this data editor. So at that same time, the data editor consists of 150 KB of code and 50 KB of data space. 50 KB of data space. So process 1 need 200 KB, process 2 need 200 KB and process 3 also need 200 KB. 50 for editor 1, 50 for editor 2, 50 for editor 3, that is 150 KB for common and 50 KB for private data, that is shareable data and that is private data. So total each and every process required 200 KB. 200 KB for process 1, process 2, process 3 and that 200 KB used by 40 users. So at the end we need 8000 KB. How it is? 150 plus 50, that is 200 KB for all the process, and we have 40 different users which have to access this memory. So for support 40 users we need 8000 KB space. Now instead of using a different pages, we use a shared page. So what will be happen when we are using this shared pages? In the shared pages, for example, 40 users need to access this memory. So for editor 1, editor 2 and editor 3 contain 150 KB and data 1, data 2 and data 3 contain 50 KB of each. So when we are using sharing, so editor 1, editor 2 and editor 3 need 150 KB for all. Process 1 need 150, process 2 also need 150 and process 3 also need 150. So at the end it is a shareable. So the copy of each and every editor contain only one for 40 users. So at the end we need 150 KB for the text editor, that means for the shared pages, plus we need 50 KB of data for process 1, process 2, process 3 for 40 users. So for 40 users only different memory we require, that is 50 KB. So 50 into 40, that is 2000 KB plus 150 is common for every user. So at the end we required only 2150 KB for 40 users instead of 8000 KB. Fine. So it is required, or it is taken less memory space in the physical memory. Fine, all of you. Okay. Bye.